What's up, Algebra 2? Here we are with 6.3 day 1, our first day with square root functions. Okay, our parent function here for just the basic square root of x. Alright, we're starting at 0, 0, and we're going up 1, 1. The next nice point is going to be at 4, 2, and on we go. It has a definite start point and then goes forever in this direction. So our domain and range is a little bit different. We're used to having at least one of them be all real numbers, but because we have a definite start point and go forward from there, our domain and range are going to be greater than or equal to a certain number for each one of these, depending on where your starting point is. So for just the base one here, square root of x, our start point is 0, 0. So all of my x's are greater than or equal to 0. All my y's are greater than or equal to 0. Okay, yesterday we had a little sneak peek at when we were doing inverse functions. We had one with x squared and the square root of x. Okay. And we saw that they both have 0, 0. And we talked about how that point kind of relates back to our first day with inverses when we were just switching points, switching the coordinates of a point. The x became the y became the x. So 0, 0 would flip to 0, 0. And 1, 1 would still flip to 1, 1. Okay? And then after that it changes, because then we have 2, 4, and that one would flip to 4, 2. Okay, so we can still kind of use our points pattern for x squared, but kind of got to reverse it a little bit. Okay, so we're going to need 0, 0, or your start point, and then from there you're going to go over 1, up 1, and then from there we go over 4, up 2. Okay, we're going to need those 3 points, those first 3 points, your start point plus the next 2, every time. And then if we can fit it in, we'll go 9 over 3 up. Okay? Alright, think back to chapter 4 with our x squared graphs and our transformations and our shifting that we did with those. Okay? Same rules apply for the square root. We have our a multiplier out in front that stretches or shrinks it down. If it's a small multiplier like a fourth or a half, a negative a is going to flip it upside down instead of going up and to the right. Inside the function with x, it's next to x, it's inside with x, so that's our hint that it's left to right. And inside is the tricky one. Inside is opposite of what you want to do. So because the minus is built in as part of the equation, when you see a minus, it's going to go to the right, and if you see a plus in there, it actually means that h was negative, and it's going to push it to the left. Outside is going to be our k value, and that's going to be our y shift, and that is normal. That is what your brain wants to do. Positive goes up, minus goes down. All right. Flip it over, and let's see what's going on. We're going to start off with our basic one here. Y equals the square root of x. I know we did a lot of that already on the front side. Let's just talk about it. Square root of 0 is 0. So we have 0, 0. Square root of 1 is 1. So we have 1, 1. Square root of 2 is not so pretty. Square root of 3 is not so pretty. Square root of 4 is 2. Okay? And these are the opposites of our x squared pattern. 0, 0, 1, 1, 2, 4. Now we're going 4, 2. Okay, and we can fit it in. So we're going to do 9 over, and the square root of 9 is 3. And we got our graph slowly going up and to the right. I think it's a good idea to label our start point, okay, because our start point tells us so much about our domain and range, which we will have to do for all of these problems with square roots. because it varies, it changes every time. It changes every time based on where your start point is. Okay? So our domain is x's, and our x-coordinate of our start point is 0. So how are the rest of our x's related to 0? Well, I have 0, then I have 1, then I have 2, or 4, 4 over, then I have 9 over. So my x's keep getting bigger. So my x's are greater than or equal to 0. We do use 0, and all the rest of them are bigger. Same thought process here for the y's. Our range, our y values, and again, the y-coordinate of our start point is also 0. So how are my y values related to 0? Are they bigger or are they smaller? 0, then we got comma 1, comma 2, comma 3. They're getting bigger as well. So greater than or equal to 0. Alright, so there's our base function, our parent function. What if we throw on a square root of x with a minus 2 on the outside? Alright, let's take a look. Let's have you push pause and go ahead and give that a shot. Okay, welcome back. On the outside, we talked about controls up and down, our vertical shifting. So a minus 2 is going to shift everything down 2. So instead of starting at 0, 0, we're starting at 0, negative 2. We don't have any multiplier on the front, so our pattern is exactly the same. Over 1, up 1. Over 4, 1, 2, 3, 4, up 1, 2. And we can fit this one, so we'll do 9 over 5, 6, 7, 8, 9, up 3. Okay, slow curve up and to the right. Okay, we're at 0, negative 2. So domain, how do my x's relate to my x-coordinate of my start? How do they relate to the 0? My x's are greater than or equal to 0. We keep getting bigger, we're going to the right. My y's, how do my y's relate to negative 2? They are greater than or equal to negative 2. Alright, we're going up. Let's see what happens if I move that minus 2 inside the square root sign with x. How does that change things? Okay, go ahead and push pause and think about that one on your own for a little bit. Okie dokes, let's see what happens here. Minus 2 on the inside. On the inside, we're going left or right. Okay, it's right next to x. That's our hint that we're sliding left and right. And it's opposite. It's a tricky one. Minus 2 is actually going to go 2 to the right. So our start point is 2, 0. Okay, no multiplier in the front. So it's our normal pattern of over 1, up 1. Because if we go over 1, the square root of 1 is 1. If we go over 4, 2, 3, 4, the square root of 4 is 2. And we can kind of squeeze 9 in. It's just going to be just off the edge. And the square root of 9 would be 3. We're starting at 2, 0. So our domain, our x's, are going to be related to 2. 2, 3, and then 4 over would be 6, 11 over here. Okay, we're all greater than or equal to 2. And our y's, 2, 0, how do our y's relate to 0? They're 0 and up. So my range, we have y's are greater than or equal to 0. Okay, One last little tiny one, and then we'll get into the fun ones. What happens if I throw that negative 2 in the front of the square root as a multiplier? There's no left and right shift inside. There's no up and down shift outside. Think about what that negative 2 multiplier is going to do on the front. Go ahead and push pause and give that a try. Okay, so no left and right, no up and down. All right, we're starting at 0, 0. So that negative 2 is going to be a stretch, all right, that we're going to apply to our pattern. Now, a couple ways to think about this. Number one, the negative means we're going to be going down, and then double your pattern. Or you can just think about your pattern and multiply that by negative 2. So over 1 would normally be up 1, but up 1 times negative 2 is going to be negative 2, so we're going to go over 1, down 2. Okay, the next spot, we go over 1, 2, 3, 4. If we go over 4, normally we go up 2, but we're times negative 2, so we're going to be down twice as much, so down 4. 1, 2, 3, 4. Okay, the next nice one is 9. Normally 9, we go up 3, but we're times negative 2, so we're going to be going down and down twice as much. So up 3 turns into down 6. 1, 2, 3, 4, 5, 6. And there we go. Let's think about how this is going to change our domain and range. Okay, our start point was 0, 0. So how do my x's relate to 0? Well, I'm at 0, I'm at 1, 4, and 9. My x's are still getting bigger. But our range, 0, negative 2, negative 4, negative 6, our range, our y values are going down, so here we finally have a less than or equal to. Okay, we got some fun ones coming up. We got two things going on at the same time here. Square root of x plus 3 on the inside minus 5 on the outside. Okay, plus 3 on the inside. It's next to x, that's our hint that it's left and right, and it's plus, so we're actually going to do opposite when it's inside. So we're going to go backwards, 3, minus 5, controls our vertical, we're going to go down 5. 1, 2, 3, 4, 5. No multiplier on the front, so it's just a normal pattern. Over 1, square root of 1 is 1. Over 1, 2, 3, 4, the square root of 4 is 2, up 2. Over 4, 5, 6, 7, 8, 9, the square root of 9 is 3. 1, 2, 3. Okay, there's our graph. We started at where? 3 over, 5 down. That's negative 3, negative 5. So my domain, my x's, we're moving to the right. They're still bigger. My x's are greater than or equal to negative 3. And my y's, we're starting down low at negative 5 and going up, so we're getting bigger still, greater than or equal to negative 5. Last one for you here. Negative square root x plus 2 on the inside plus 7 on the outside. Okay, go ahead and push pause and give that some thought. Okay, let's see how we're doing. So this negative is going to make it go down. Plus 2 on the inside, left and right, opposites. We're actually going to go backwards 2. Plus 7 on the outside, up 1, 2, 3, 4, 5, 6, 7. We're at negative 2, comma 7. just a negative sign, a -1 basically on the outside. So we're going to go points pattern, our normal pattern, but just down instead of up. So over 1, down 1. Over 1, 2, 3, 4. Down 1, 2. Over 5, 6, 7, 8, 9. Down 1, 2, 3. Okay, we're slowly going down and to the right. Domain. How are my x's related to the x-coordinate? -2. We're still going to the right. My x's are still getting bigger. -2, -1. Okay, +2. They're getting bigger. Greater than or equal to. Range. How are my y's related to 7? Well, we're going down. 7, 6, 5, 4. So all my y's are less than or equal to 7. All right, so this is what we're doing today with our square root function. Tomorrow we are going to add in some more complexities, some more stuff under the radical, talk about what we'll do with that. So stay tuned for more fun. Best of luck on your homework, and let me know if you have any questions.